Thank you, Professor Xi. Thanks for your introduction. I'm Du Jianghui, and I'm a PhD student. I'm going to this speech on behalf of my tutor, Professor Liu Dezhao. This title is Research on the Removal of Trans Ammonia Containing Odor by Short-Term Biofilm Method. Odor emissions from livestock production contribute to several air pollution, causing negative impacts on animals and residents. These odorants mainly include ammonia, sulfur odorants, and other VOCs. In this work, we mainly solve this problem by using biotrickling filter, BTF. BTF is a green and effective method for the treatment of odor pollution. The odor could be decomposed to the harmless products. This is my first research. We studied the interaction and microbial variations in biotrickling filter treating low concentration for hydrogen sulfide and ammonia. With the EDBRT at 10 to 20 seconds, the maximum IE of stage 1 and stage 2 was more than 9%, 90%. Here is the microbial analysis. It shows that the similarities among the communities was low, and the microbial diversity of BTF significantly increased due to the introduction of ammonia. Based on the research one, we conduct the next research. We try to research the microbial and isotoper analysis of nitrogen oxide generation. In ammonia removal biofilters, higher moisture content of 55% produced more nitrous oxide than that of 45%, but without ammonia removal increase. It shows that the nitrification was demonstrated to be the dominant pathway for nitrous oxide generation. Next, we try to introduce the P-cruciso as a carbon source. We researched the impact of P-cruciso on hydrogen sulfide and ammonia treatment by BTF and the production of nitrous oxide. With the EDBRT at 1.9 to 4.7 seconds, the presence of P-cruciso promoted hydrogen sulfide removal with no clear effect on ammonia removal. Microbial enzymes show that relative abundance of microbial generous towards to denitrification increased when P-cruciso presented. In the next work, we make a research about the simultaneous removal of ammonia and sulfur odorants in BTF and nitrous oxide production. In this work, we faced this board challenge. Number one, the low RE of sulfur odorants and the low temperature, and the low EBRT. Number two, the low temperature. Number three, starvation or recovery during the BTF operation. Number four, blocking for BTF will have a bad influence on nitrous oxide production. We compare two different packings, properly plastic. We call it PP, and chemical researching rings. We call it CR. The PP, it has a 3-dimensional structure and it has a larger space. This is the BTF operation state. We conduct about 500 days experiment. Here is the result. The minimum ammonia of ammonia RE of 14% for PP and 19% for CR in the beginning. The hydrogen sulfide removal of started with at 94% and decreased to 81%. This is the DMS with the EBRTS at 7.2 seconds. The DMS IE of 2 BTF stipulated a relative high level of 83%. After the starvation, we found that the recovery order of these 3 air from high to low is ammonia, hydrogen sulfide, and DMS. A significant correlation between the emission for nitrogen sulfide and the pressure drop, and the correlation is stronger in the CRBTF. And this initial excited emission was mainly related with the type of packing. The microball shows that the packing type and temperature of BTF affect the buildings and the structure of microball population. The left analysis shows that a total of 6 biomarks at the family level were identified as the physical from a starvation. And the biomarks will be changed due to the environmental factors. This is the functional genes and degradation mechanism. The ammonia could be absorbed by circulation water and removed by the nitrification and denitrification process. And the sulfide will be organized to elimination sulfur and further converted to sulfide. This work was published in Bioresource Technology. Based on the last research, we found that the transfer sulfur odorants, the removal efficiency of trans sulfur odorants is not good under the adverse conditions such as the low temperature. So we try to find some way to improve the low efficiency, the low RE of sulfur odorants. We use the PP packing because it has low pressure drop, but the negative was biological attachment. So we use 2 different methods to make a modification. The first one, we use the plasma combined with chemical solution. So we called it PP at PC. P mean plasma, C mean chemical solution. And another modification method, we called it, we use the rice husk active carbon because we use the rice husk as a raw material to make the activated carbon. We call it PP at PC. And we use the SBS as the surfactant to enhance the absorption of DMS and DMDS. The modification by the objective include roughness, hydrophily, and microball attachment. It shows that compared to the PP, the initial packing, the conductor angles of PP at PC and PP at AC reduced by 5 and 15 degrees. It suggests that a higher water absorption. The startup was shortened by about 20% in PP at PC BTF and 30% at PP at AC BTF. The pressure drop of BTF from high to low, PP at AC and PP at PC and PP. That means the PP at AC packing showed a higher biomass accumulation. The number of unique species in PP at PC bioform increased during the starvation and low temperature. You can get microbial diversity improved. This is the correlation head map. So that these 4 different microbial positive correlated genes related to metabolism occur for the largest portion. Here is the pathway of sulfur metabolism based on the KGG innovation. This work was published in Chemical Engineering Journal. In the next work, we try to add extraneous additives to simulate the production of a signal molecule, enhance the trans-sulfur odorants, BTF, and low temperature. This is the BTF operation stage. It shows that with the 3 milligram Fa, Fa means fluoric acid. These two signal molecule was generated in sequential liquid. Here is the signal molecule stress the interaction between different microorganisms. This is the signal molecular regulation pathway. In the next work, we try to find a new method to reduce the generation for nitric oxide, and we found this new process. We call it dynamics process. In this process, the ammonia could be directly transferred into nitrogen. This is the process, and in the first step, we try to enrich the dynamics bacteria. And with the EDBRT at 10 seconds, it shows that the DABTF, DA means dynamics BTF, can be reduced the nitric oxide about over 30%, and adding 200 to 300 milligram per L of H2OH to the circulating water can be from the transformation of NA to NBTF to DBTF. This is the pH and other. In next work, we try to research the ammonia, the methanol removed with the disturb of ammonia. This is the BTF operation stage. It shows that ammonia removal increased by over 17% average. This is the functional generation and pathway of the next generation for ammonia and methanol. Next, the last one, the family one, is we try to use the acid pH BTF to reduce the nitric oxide emission. I think there is no time to introduce this. So this is a challenge we want to solve. And this is the information of my tutor, Professor Dezhao. Thank you.